Okay. Okay. So taking these into account is the fact that we can take advantage of surface constraints to fix solutions. Okay. This is pretty much important, maybe a little bit advanced. But the idea over here is that we have our topography. For example, we might have our mine design. So what if we take these open pit mine design in terms of a grid of point, or translate it to a grid of point, and how we could incorporate it into a new optimization to re-optimize the scenario. So the idea here is that we will use this mine design surface as a minimum depth. So this is the minimum depth we should achieve along all over these directions, all over these points. Okay, so it should, the optimizer should at least mine the surface, this blue surface, which represents the mine design. So we can use this mine design in the field of forest mining to do so. Okay. Complementarily or additionally, we can also use the same mine design into the restricted mining, so we can ensure the optimizer will not surpass that solution. This means that minimum equals maximum, which is the exact solution. Okay, so when we use something into the forest mining, we use something into the forest mining equals in the restricted mining, we are saying the minimum depth is equal to the maximum depth. It means that this is the exact solution I'm looking for. This solution is already considered acceptable or the best one for that period. So I'm using this concept of exact solution to combine MiningMath optimization with mine design made in other softwares. Okay, so this is the main idea of taking into account. So here you can see the exactest result. On the interface, it will be the following thing. Let's imagine we have designed the pit from paired 1 to 1. So we have, for example, here we have the design. Okay, and here we would also have the same design file. Okay, from paired 1 to 1. And maybe we want to iterate. We have made a free optimization like this way. Then we understood the scenario was the best from our decision tree, and then we bring back the mine design for paired 1. Then we re-optimize it so we can have flexibility to redefine the following mining sequence for the rest of the life of mine. And then we believe, well, paired 2 is even better than before because of this new circumstance, which is a more operational result for paired 1 to 1. Then you can, for example, design the same for paired 2 and iterate over it again, and then repeat this process over and over up to the point where you have the entire life of mine with the mine design as well. Okay, so this is a concept which is pretty much important to consider fixed solutions. Okay,